sorry gene because it triggers male development. So that's their jab at all the male scientists in the world, I guess. So the sorry gene is a gene that turns on male development. So if at a critical stage in fetal development, this gene produces a product that will cause my body to produce testes. My testes will then produce testosterone, and the development will be male. If I don't have a Y chromosome, obviously, I'm not going to produce testosterone, so the default development is female. So the gonad will become an ovary, start producing estrogens and eggs, and the normal development will be female. Similarly, what if I have a Y chromosome, but this is mutated? What's my development? Female, and you know what? Every bit as female as if I would have been XX. Okay, you all right with that? So this idea of genetic testing for gender of female athletes is pretty stupid because the biology doesn't support any of that. They've actually taken awards away from female athletes that have tested XY, even though they are as female as an XX individual, because there's nothing about having this Y chromosome that makes them, more male-like at all. Right? XX females have all the same genes. Right? It's just that they're not expressed. But if things go as normal, this sorry gene produces a protein. And the protein that is expressed from the sorry gene is called the testis determining factor, or protein. We call it TDF. And what TDF causes, it causes in development the production of testes. And once you have testes, they start producing testosterone. And once you have testosterone, the development is male. Okay? So that's kind of the chain of events that would occur. Now what that must mean is that early on in fetal development, every individual, every fetus, must start out as neither male nor female, right? But as potentially male or potentially female. We call that bipotential. So for the first 6 to 8 weeks of gestation, so the first 6 to 8 weeks of development, a fetus is neither male nor female. It is potentially male if it has a Y chromosome and the Y chromosome works, or it is potentially female if it doesn't have a Y chromosome or the Y chromosome doesn't work. But it is neither male nor female. It is potentially either one. So if we look at that, and that's why, like when they do when they look at a fetus on an ultrasound or something like that, and they try to determine whether that fetus is male or female, they're not really good at doing that until about 12 weeks. Sometimes at 10 weeks, but not until about 12 weeks. Why? Because the male external structures are not developed enough to be able to see until that point. Now they can do genetic testing and see if there's a Y chromosome or not, and they'll do that. But as far as looking at the phenotype of the fetus, you can't see that until about 10 weeks or so. So here's what we start out as. We start out as this bipotential structure. If you'll notice, so these would be the lower limbs here. You can see the kidneys, the urinary bladder. You can see what is going to be a gonad at this point. We don't know whether it's a testis or an ovary. And we see a series of ducts in there. And these ducts are either structures that will develop and become male duct system, and by that I mean like the epididymis, the vas deferens, right? Or they're a set of ducts that will become the female duct system, and by that I mean the fallopian tube predominantly. Right? If this structure develops into a male, it will develop this testis, this gonad will turn into a testes. We'll get rid of the female ducts and we'll mature the male duct system. Conversely, if it's female, this will become an ovary. We'll get rid of the male duct system. It'll actually become an ovarian ligament, and we'll develop the female duct system. Now, the female duct system in a bipotential structure is called the Mullerian duct, okay, and the male is the Wolffian duct. Okay, so the Mullerian duct would, in the absence of testosterone, become the fallopian tube. In the Wolffian duct, in the presence of testosterone, would become the epididymis and the vas deferens. Now, so that's the internal genitalia. So you'll start to see changes that occur, right, as a result of that. In the absence of testosterone, the development is toward the female structure. In the presence of testosterone, the development is toward the male structure. Now, this is the internal genitalia. We also know, right, that there are external genitalia. Oh, it's interesting, I should point out, is that you'll notice that the testes, the bipotential structures in the abdominopelvic cavity. And you know that testes are housed in the scrotum for temperature regulation. So at some point during fetal development or shortly after birth, the testis has to migrate from the abdominal cavity down into the scrotum. If it fails to do that, it would be sterile, yeah, because it wouldn't develop properly. And that's called, this is funny. Oh, not funny, it's interesting. Orchid is the Latin name for testis. Okay, so it's orchid. And hidden would be crypt. So cryptorchidism is when a testis fails to descend. Now, if the testes, if a boy is born, if a male is born, and the testes are not descended, they'll give it a little bit of time to descend. If they don't descend, they'll surgically move them down into the scrotum. Yes, that